Okay, this is it, part 3, and I'm going to get done in less than 8 minutes. So I'm taking a while. I shouldn't tease Miss Bryan for talking a lot because apparently I do too. So we have a total of 6 slides. I'm on the last slide, and I just have to finish some of these up. All right. So we have right here for 39 something that could be regarded as being just an element. Chlorine, however, in nature doesn't occur as an element. It always occurs as a diatomic molecule. So if we wanted to say we were talking about atoms of chlorine, we could say that this is an element, but actually we should be talking about it as what we would call a diatomic molecule. It always occurs in twos. It's more stable that way. All right, so phosphorus trichloride. We have phosphorus, we have chlorine. This is a binary covalent compound. Now, there's no prefix in front of phosphorus. That means I have 1. We would never see a mono here first. And I have a tri in front of chloride, so that means I have 3 chlorine, and the 3 comes after the chlorine. Okay? If I go down to cadmium sulfate, cadmium is a metal, sulfate is a polyatomic ion. This is an ionic compound. Now, cadmium, this is special. It's on the sliding board. It's in group 12. So it always has a charge of 2 plus. It's right under zinc. So cadmium has a charge of 2 plus. And you'll remember probably that the sulfate ion is SO4, 2 minus. If you take a close look at this then, 2 plus, 2 minus, hey, one of each. We're going to go ahead and write the name of it, or the formula for it rather, CdSO4. Dihydrogen oxide, kind of silly, but it is what it is. Dihydrogen means 2 hydrogen. Now, there's no mono in front of this oxide, and sometimes you see that. Sometimes you actually see carbon oxide, but it's carbon monoxide. So technically, there should be a mono in front of here, but sometimes it's omitted for whatever reason, and so there's 1 oxygen. You probably recognize this as water or good old HOH. Up here, we have a funny looking thing that has mercury in it. So I know since it has mercury in it and mercury's a metal, it's an ionic compound. The thing about this that looks a little weird is that we have not reduced these subscripts to the lowest whole number ratio. If we did, it would be HgBr. Well, we can't do this because this mercury is a polyatomic ion, and we can never ever change the subscript of a polyatomic ion. So this is a heads up to you that I'm talking about mercury 1. Now with mercury 1, keep in mind the charge is 2 plus, but it's only because we have 2 mercury 1s of 1 plus each that are attracted to each other to form this ion. So if I were to look at it another way, bromide, each one of them has a charge of -1, which is a total collective charge of -2. If this is the case, the total positive charge of mercury would be 2 plus. So that's where I have my Hg2, 2 plus. So of course then what I'm saying is mercury 1, the reason it's called that is because you actually have a diatomic molecule with these 2 mercury 1s attracted to each other, Hg2, 2 plus. So this is called mercury, and we have to use the Roman numeral 1 here, and it looks like a 2. I know it looks like a 2, but it's not bromide. So go back and rewind that and listen again if you're still confused. We have a nickel, we have a nitrogen, we have an oxygen. So I have a metal, bam, I have an ionic compound. Now, this guy right here, if you look at your reference sheet, this is not nitrate, it's nitrite, 1 oxygen less. The charge is 1 minus. We can tell there's only one of these because there are no parentheses. Don't be fooled. Some people look at this and they see the subscript of 2 and they go, yeah, there's 2 nitrites. Well, no, there's not. There's 1 nitrogen, there's 2 oxygen. That makes 1 nitrite when it has a charge of -1. So if there's one of these and there's 1 nickel, that means nickel's charge has to be 1 plus. So we have to give nickel a Roman numeral. Nickel 1, you could put parentheses there if you wanted to, and then the anion is called nitrite, not nitrate. Nickel 1 nitrite. Again, nickel, not in group 1, not in group 2, not on the sliding board. It needs a Roman numeral. You could also have nickel 2. Down here, silicon, fluorine. both to the right of the stair-step line, both nonmetals, binary, covalent, compound. So 2 silicons, this is going to be di. Silicon, not silicone, but disilicon. This silicon does not change. We simply stick a di in front of it, and then we have 6 fluorine. So we've got hexa, and I'm going to say fluor, and remember the ending, oops, the ending changes to I, D, E. Disilicon hexafluoride. This last one here that we have is a little bit interesting. You don't see this a lot, but you can see that there's a metal here, so we definitely have an ionic compound. So what's up with this? Well, this hydrogen actually is part of this phosphate ion, and we call it hydrogen phosphate. Now, phosphate typically has a 3- charge, but if we take a proton and we add it on to that, what that means is that the charge on the hydrogen phosphate ion is not going to be 3+, or excuse me, 3-, it's going to be 2-. Now, if that's the case, we have one of these, there's no parentheses involved, don't look at that 4 and think there are 4 of them. We have one of these hydrogen phosphate ions, so we have one of these and we have one titanium, then that must mean that the charge in the titanium is +2. This would give us, are you ready for this? I don't know if I can fit it on here, but I'm going to try. It will be titanium. And it's going to need a Roman numeral, that's why I figured out the charge, 2 hydrogen phosphate. All right. So that took a while, folks, but anything that's worth it in life is worth taking the time to do well in. You have to make sure to hone those study skills so that you are going to be a better student. If you don't do it now in high school, then you're going to have to do it later. So take advantage of the gift that you're given in your public education. Work hard so that you can graduate from here, go to a good college, and do well in college